All right. All right, so in this video, we're going to look at mass versus weight. And you know what it has to do with? B, that was a great yawn. I mean, you know what I mean? If you're going to be bored and yawn, at least entertain somebody when you do it. You looked like your entire body yawned. That was really weird. I thought your mouth was going to open up and wrap around your head and consume it. It was really weird. I thought it was going to go like this, and the lips were going to come back here and cover her head, and her head being dragged into her shoulders and disappear. Exactly. Unbelievable. I'm in the presence of greatness. That was a great yawn. Okay, good. Now, this has to do with Newton's second law of motion. Really weird. It has to do also with gravity. Okay? Yes? And you know what else? We've already talked about this. Okay? Now, let's just state Newton's second law of motion. It says that force equals mass times acceleration. When I accelerate a mass, don't you feel that force that you're applying? You can't see it, but you can feel it, right, Isra? Yeah. You can feel it, right? Okay. Let me ask you this. Let me ask you something. Okay. Let me ask you something. All right. Pick up your book. You don't have a big book, but pick up your book. All right. Close it. Okay. Now, everybody do it. Tarek, you got to do this. Everybody's got to do it. All right. Give me a small book too. You're going to use a big book? Yeah, bring it. Yeah, if you have a big book, use a big book because it's really cool with a big book. Okay, now, go like this. Go like this. Now, do you feel that you have to change, when you change direction, you're applying a force, okay? When you go left, you feel your left hand, don't you? You feel that? It's kind of tiring. Don't twist like that. Oh, yeah, you can do that if you want. But you go like this. Stay still and go like this. Do you feel that back and forth? Do you feel that? Can you feel an up and down or left and right? You don't feel up and down, do you? No, you don't really, do you? Not really. But you feel this, don't you? If you go like this, you feel it, right? But don't go like that. Go like this. Yeah? You feel that? Yeah. Okay, now put it down. Now, let me ask you a question. If you're in outer space, deep space, and you're living, because it's magic, okay? And you did that with your book. You were there. What would it feel like? Would it be the same? What would it feel like?
You would feel lighter.
It would feel lighter, but you said it didn't feel heavy. But you're just going back and forth. What would it feel like? You know what it would feel like? It would feel exactly the same. Because listen to what Newton's first law is. Newton's first law is inertia. An object will stay in motion unless acted on by an outside force. This way, change, force. I'm applying a force when I change direction, aren't I? Aren't I applying a force? Every time I apply a force, aren't I changing the inertia? It's going this way, I get it going, then I change my mind. Going, yes, change. Aren't I? Yes or no? Yes or no? So isn't inertia, aren't Newton's laws consistent throughout the universe? To the best of our knowledge, they are, of course. Aren't they? Yes or no? Yeah. It would feel exactly the same. It wouldn't be heavy. If you sat there like this, you wouldn't feel it heavy. But if you're going like this when you're changing direction, would it feel heavy? No, because it's stationary. The inertia says that it's not moving, right? So it's not going to feel heavy because you have no gravity, right? Right? But if all of a sudden you go like this or this, aren't you changing direction? What allows you to change direction? What allows you to change direction? The force, right? What did I say? Inertia is an object in rest will stay at rest, or an object in motion will stay in motion unless acted on by an external net, not a net force, right? You get it? Isn't that true? Aren't I applying a force every time I go change direction? Aren't you doing that in space? right? Yes or no? So what you're doing is, when you apply a force, isn't this a mass? Yeah, it's heavy, but isn't this a mass? Isn't it? I go like this, aren't I accelerating it? Accelerate, 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 aren't I? Yes or no? Matter of fact, it doesn't really stop accelerating, does it, when I change direction? Yes? It's not going at a constant velocity, is it? It doesn't have time, because it's so quick, right? Well, guess what? You know what force is? I take that mass, the book, I keep changing direction. That's a force, man. That's what force is. Right? Easy? Now we're on Earth. Welcome back. It was good to get away, wasn't it? But isn't it better to be back on Earth, to be back? Welcome back, everybody. It was a nice trip. Excellent. We were in deep space. It was a lot of fun, actually. But now we're on Earth, and here we are. This is our mass. That's our mass. Okay? Yes? This is Zaid. Okay? Right? And he has a mass, right? He has a mass. And isn't he accelerating? Right? I know it's weird. You're not moving, but you're accelerating. Really weird, but deal with it, okay? You understand? Okay? I'll give you a little bit better of an explanation next week, whatever. Okay. So you multiply that by gravity. See, when A is free fall or just vertical acceleration, gravity, A, that means defined as 3 lines, G. Right? Yes, do you get it? Does that come up? Can you see that? Yeah. Okay, so we can say W. What's that? Wait. Zaid, you are on fire. On fire. Yeah, I'm telling you, is anybody here besides Zaid today? I mean, unbelievable, right? Yes? No, yeah? Equals mass times what? G, right? So mg. So mg. What's the mg? Or people just say, what's the G, baby? How many G's was it? How many G's, okay? How many G's, okay? How many G's? You ever hear that? Hey, he was pulling 11 G's, man. You know what I'm saying? 11 G's. Whoa, 11 G's. That means you weigh 11 times what you normally weigh. You ever see the movie Armageddon? No, man, you're too young. It's like with Bruce Willis, and they go to an asteroid and they save the universe, and it's completely implausible, but it's fun. You ever see that kind of movie, science fiction movie? Dumb science, but fun, okay? And well, they were pulling 11 G's when they went around the moon. That literally means you feel like you're 11 times your weight. 11 G's. 11 G's, it's short for mg. M times G. Yeah, 11 G's, you know what I'm saying? How many G's am I pulling right now? How many G's?
11.
No, right now.
Oh, 0.
No.
1.
1. 1 G. Only 1 G.
Why?
Because that's my weight. It's times 10 meters per second squared. Remember? My FW, Mr. Darcy's FW, I'm telling the entire world my weight. Isn't that weird? Okay? Is going to be 100 kilograms times 10 meters per second squared equals, is this on the board? Is this on? 1,000 newtons. Right? Remember we did that?
Yeah.
Remember we did that? A newton.
100 kilograms?
Yeah. Is that big? I'm a big guy. Okay? They call me the big guy, you know what I'm saying? Yeah? Yeah? You want a piece of this, huh? No. Believe me, I'm like, my 4-year-old granddaughter could take me, okay? I mean, I'm telling you. Just one hand behind her back and she could go. and I fall to the floor in a heap. Okay? Newton. N. It's going to be kilograms, meters. Remember we did that?
Yeah.
That's mass times acceleration. That's mass. That's acceleration. Mass times acceleration. Kilogram meter. You know how you say that? Say it together with me. I'll say it first. Kilogram meters per second squared. 1, 2, 3. Kilogram meters per second squared. Now you say it. Excellent. Now you guys, you know what you sound like? You sound like a bunch of nerds who really do physics well, and that's a compliment. Trust me. I like that. That's really cool. You guys sounded great. Can you do this once more? Can you say it together on the count of 3? Kilogram meters per second squared. You guys sound, I feel like I'm at this prestigious university, okay? All right, say it. 1, 2, 3.
Kilogram meters per second squared.
And it's amazing how 7th graders can sound like a chorus so easily. I do it with my 10th grade chemistry class, and they can't do it. All right, I'm going to prove to the camera. This is unrehearsed, okay? You ready? Well, on the count of 3, you're going to say, Mary had a little lamb. Her fleece was white as snow. That's it, okay? You ready? All right. All right, you can say it to yourself, and then when I say go, then we're going to do it. And I'm going to show the audience that you can really do it unrehearsed. There's something about 7th graders that they have this like, it's like the Force. They're like Jedi Knights. They know how to do this unrehearsed. Are you ready? Okay, so we're going to say it together with me, whatever. Mary had a little lamb. Her fleece was white as snow. All right? Mary had a little lamb. Her fleece was white as snow. Now we're going to say it together in unison for the folks, and they're going to say, how did they do that? Unrehearsed. Are you ready? On the count of 3, I'm not going to talk. You ready? Really belt it out. Okay? Right? Stop yawning. Feel better? That was a good yawn too, by the way. Okay? 1, 2, 3.
Mary had a little lamb. Her fleece was white as snow.
Weird. I do with my 10th graders, and it's like, Mary over here, Mary, had a little lamb, Mary, a lamb. Can't do it. But 7th graders, unbelievable. Okay. So, mass is just what? What is mass? What is mass? Mass is not weight. No, that's okay. Hey, you're still on fire. Because on fire means you're participating. On fire doesn't mean you're right. I don't care if you're right or wrong. I would rather you answer 100 questions incorrectly than be quiet. Okay? So Zayd, you're on fire, baby. On fire. Okay? Okay, good. Okay? How do you say on fire in Arabic? Like you're on fire, man. How do you say it? Alanar? Did I just insult somebody or something? Or I mispronounced it. I called somebody's mother a toad or something? Or okay? All right. So you're on fire, babe. On fire. Okay, now. So mass is just a quantity. It's a quantity of matter. It's quantity, right? That's all it is. It's scalar. It's just a quantity. Where weight is you take a quantity and you subject it to gravity. Listen. Oh my God. I said, listen, didn't I? You weren't even paying attention, girl. You were busy yawning and you were swallowing your head down between your shoulders, down to your belly button. Okay? All right? You ready? This is, I'm going to demonstrate force. That was really loud. My ears are ringing. Now, a mass couldn't do that, could it? Could a mass do that? No. Oh, can a force do it? Yes. Why? Because it's hitting the ground with something extra. It's hitting the ground. It's moving. There's a movement there, isn't it? It's too complicated. I don't want to get into it. We'll talk about momentum next week. But if you take a force and you move it, do you know what that's called? That's called work. Believe it or not, that's the definition of work. Work isn't getting up at 3:30 in the morning and getting dressed and taking a shower. That's not work. Okay, work is you take a force and you move it. That's work. You got it? But a force, you need a force, don't you? So can a force make a noise like that? Yeah. Yeah. Force. There's something can do that. It's like energy. Yeah? You get it? Okay. But a mass can't do that, can it? What do you need for a mass in order so that it can be a force? What do you need? It starts with a G. Yeah, you need gravity. So when you subject a mass to gravity well, Israel, you all right? You're losing your mind, aren't you? You can't wait till this is over. Okay? You really are, aren't you? It's okay, I'm almost over. Give me one more minute. Give me all right. All right. 5-second relaxation period starting now. All right, relaxation period over. All right, give me 2 minutes, solid minutes, okay? Are you all right with that? Okay? We're going to play with equipment next week. We're going to play. Yeah! Give me yeah! Yeah! Excellent. So I take a mass. So in other words, let's look at this. What planet is a mass 1 kilogram going to have a greater weight? A or B?
A.
What planet, let's get rid of all this so we don't get confused. What planet, A or B, is going to have the greater weight? B, yeah. The more gravity, the more weight, right? So do you have the same, true or false? Your mass on Earth is the same as your mass on the moon.
False. There's no gravity.
Craig, extra credit, big guy. Sorry, I know that you don't like a lot of points. Sorry, I got to give you extra credit. I apologize. Yeah, your mass is the same because what's mass? Just quantity of matter, right? But is your weight more on Earth or more on the moon? It's more on Earth, right? So what's going to have a greater? What's going to be greater? Weight FW, FWA, or FWB? What am I going to put in between here? Greater than or less than? What am I going to put? Am I going to put this or this? Am I going to put 1 or 2? 1. How do you read that? You guys are confused. How do you read this? How do we read English? Left to right, right? It's not like Arabic. I apologize, girls. It's not Arabic. How do you read in English? You read left to right, right? Okay. Is this less than this? Is this point smaller than this? Yes. So you read from left to right. Less than this. Greater than this. You see how to read it? Did you know that before? No, people, you didn't know that, did you? Isn't that weird? That's how you read them. Did you know that? How many people didn't know that? Raise your hand. It's okay. Yeah. 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 You read it from left to right. So this one is less than. This is greater than. So you put this one in there. This is less than. This says FWA is less than FWB. Okay? You see that? Isn't that good? Yeah. Yes or no?
Yes.
Okay. We're off. We're done, man. We are done. Isra, you did well. I'm telling you. You did well.